We all have a gut feeling about what makes an argument good, right? It feels solid. The pieces fit together and it makes sense. But what if I told you that in some of our most powerful logical systems, that's not always a guarantee? Today, we're going to dive into what it really means for a proof to be pure.
So, get this. It sounds completely absurd, but in classical logic, there's this weird principle where if you start with a flat-out contradiction, saying something is both true and false at the same time, you can logically prove anything. I mean, literally anything. If I accept that the sky is blue and the sky is not blue, I can spin a logically valid proof that the moon is made of cheese. It's a fundamental flaw, really, where the starting points have absolutely nothing to do with the conclusion.
And this gets us right to the heart of a huge issue that's bugged logicians for a long time: logic's relevancy problem. The big question is, how do you build a system that only allows arguments that feel right, where the things you start with are genuinely, meaningfully connected to what you end up with?
And this is where our hero steps onto the stage. Core logic, developed by the philosopher Neil Tennant, is a system designed from the ground up to fix this exact problem. It's a really ambitious attempt to get back to the true essence of what it means to reason well.
So what exactly is core logic? Well, it's not just another flavor of the month logic. It's more like a greatest hits album. It's carefully crafted to sit right at the crossroads of several major schools of thought. It takes the power of classical logic, the build-it step-by-step approach of intuitionistic logic, and that focus on meaningful connections from relevant logic to create something totally new.
So how does it pull this off? Well, it's all built on two big ideas, two pillars. The first one is constructivization. This idea, borrowed from intuitionism, just means that proofs have to be built in a way that makes sense, step by step. The second is relevantization, which, the name kind of gives it away. It guarantees that every single piece of your argument is actually relevant to your final point. You put those two together and you get a system that's both intuitive and relevant.
Okay, so how does it work under the hood? It's kind of like Marie Kondo for logic, seriously. Core logic doesn't get its power by adding a bunch of complicated new rules. No, it gets its power by tidying up, by getting rid of all the unnecessary rules, leaving you with proofs that are pure, simple, and incredibly direct.
You see, traditional systems often rely on these behind-the-scenes shortcuts called structural rules. Two of the biggest ones are called cut and thinning. Core logic takes this really bold stance and basically says, you know what? We don't need them. The big insight here is that you can have a powerful, clean system without all that extra clutter. Let's start with the cut rule. It's basically that old idea that if A leads to B and B leads to C, then A must lead to C. It seems super useful, right? A nice shortcut for chaining arguments together, but core logic shows that actually it's redundant. You can always find a direct path from A to C without needing that middle step. By getting rid of it, you force the logic to be more direct and elegant.
And then there's thinning. Honestly, this is the real troublemaker, the one that causes that whole relevancy problem we talked about. This is the rule that lets you just toss completely irrelevant facts into your argument. It's like adding the fact the sky is blue to a recipe for chocolate cake. I mean, sure, it's true, but it does absolutely nothing to help you bake the cake. Core logic throws that rule out completely, making sure every ingredient in your proof is essential.
So if we've thrown out all these other rules, what's left? What's holding the whole thing together? Well, just one thing. A single, absolutely minimal structural rule called reflexivity. And all it says is that any statement follows from itself. That a formula, let's call it phi, implies phi. It's that simple, it's elegant, and it's all you need.
And this quote from Neil Tennant himself just nails it. He says, proofs have to get started. That's what reflexivity is. It's the starting block. It's that self-evident, rock-solid foundation that every other logical step can be built on top of.
Okay, so we've got this super pure, minimal system for building proofs. That's great. But what does it have to do with the real world? How do these abstract symbols connect with, reality? That's where this amazing idea of truthmakers comes into play.
This is where it gets really cool. The idea here, with truthmaker semantics, is that a core proof isn't just a game of shuffling symbols around. It's describing a real-world transformation. Think of it this way. If your premise is it is raining, the truthmaker is the actual rain falling from the sky. A core proof is like a recipe that tells you how to take that situation, the rain, and transform it into a new situation, like the ground is wet.
Let's just walk through it. Step 1, you identify the truthmaker for your premises. So you look outside, you see the actual rain. That's what makes it is raining true. Step 2, you apply the core proof. That's the engine. And step 3,
That process guarantees a new state of affairs, the wet ground, which is the truthmaker for your conclusion. The ground is wet. See? It's a direct bridge from abstract logic to concrete reality.
So what's the big takeaway from all this? Why does this whole quest for a purer, more relevant logic actually matter outside of a philosophy class? Well, it turns out that this super elegant system has some pretty powerful applications in the real world.
For starters, in natural science and math, its focus on constructive, step-by-step proofs is huge for making sure everything is verifiable and makes intuitive sense. And get this, in computer science and AI, because the proofs are so clean and direct, without all those messy, unnecessary rules, it's become a fantastic tool for building more efficient systems that can search for proofs way faster.
Now, of course, this whole quest for logical purity is not without its own debates. It's a living, breathing field. There's even a challenge out there in the academic world known as the core logic paradox, which pokes at some of the system's foundational claims. It just goes to show this conversation is far from over.
And that leaves us with one last big question to chew on. We've seen how core logic strips everything down to get to the absolute essence of reasoning, but it makes you wonder, in our messy, complicated world, is a perfectly pure and elegant logic always the most useful one? That's something to think about. Thanks for tuning in.